Energy cannot be destroyed, not by fire, not by time, not by anything the universe has ever done in 14 billion years. This is not a belief. It is the first law of thermodynamics, and it has never once been broken, not in a lab, not in a star, not in the death of a galaxy. And yet, right now, you are going to die. Every atom in your body will still be here in a billion years. The energy that powers your heartbeat, that fires the thought you're having right now, that arranged itself into the exact, unrepeatable pattern of you, none of it can be destroyed. Physics forbids it. So here is the question tonight's video is going to sit inside, and refuse to let you leave until you've felt the full weight of it. If nothing about you can be destroyed, what does it actually mean that you're going to disappear? By the end of this video, you will understand the actual physics of what happens to a human being at the moment of death. Not the biology, not the poetry, the physics. And you will find that the universe has an answer far stranger and far more precise than anything religion or science fiction has ever offered you. You already know intuitively that nothing really disappears. Watch an ice cube melt. It doesn't vanish, it becomes water. Leave the water in a warm room and eventually it becomes vapor, invisible, dispersed into the air of the room, then the building, then eventually, technically, the atmosphere of the entire planet. At no point did the water stop existing. It just stopped being organized in a way you could point to and call ice cube. Burn a log in a fireplace and the same rule holds. The log doesn't vanish into nothing. Its mass converts into heat, light, carbon dioxide, ash, and trace gases that drift out into the world and eventually become part of new trees, new soil, new organisms. Chemists have known this for over 200 years. Antoine Lavoisier proved it in 1789, and it has never been overturned. Matter is neither created nor destroyed, only transformed. You have lived your entire life surrounded by proof of this law. In every flame you've watched go out, and every ice cube you've watched disappear. You've simply never applied it to the one transformation that terrifies you the most. There's a second law hiding behind the first one, and it's the one that actually matters here. In the 1850s, the physicist Ludwig Boltzmann was trying to explain something that seems obvious but had never been mathematically proven. Why does an ice cube melt into a puddle, but a puddle never spontaneously refreezes into an ice cube on its own? Both directions conserve energy perfectly. Nothing in the first law forbids a puddle from reassembling itself into ice. And yet you have never seen it happen, and you never will. Boltzmann's answer became the second law of thermodynamics. There are vastly more ways for water molecules to be arranged as a disordered puddle than as an ordered ice cube. So statistically, disorder wins. Not because the universe wants disorder, because there are simply more ways to be disordered than to be ordered, and given enough time, the odds always collapse in that direction. This single insight, more ways to be broken than to be whole, is the actual engine behind everything this video is about to show you about death. So apply it now. At the moment you die, your body does not stop existing in any physical sense. Every carbon atom, every oxygen atom, every trace mineral that made up the machine that was reading these words a moment ago, all of it persists, obeying the same first law that governs the ice cube and the flame. Cremation converts your body's mass into heat, gas, and a small amount of mineral ash. The same energy conservation process as any other combustion. Burial returns you more slowly through decomposition, bacteria, and soil chemistry, but the end state is identical: dispersal, not destruction. This is where most explanations of death and physics simply stop. Your atoms return to the earth. You become part of the universe again. It sounds comforting. It's also, physically speaking, almost entirely beside the point. And the moment you understand why, this video is going to feel very different than you expected. Because the atoms were never the interesting part. The interesting part, the part physics actually struggles with, is something else entirely, and it's hiding in plain sight in a single word you've heard your whole life without ever asking what it costs the universe to destroy. Information. Here's the explanation most people settle for. And it isn't wrong, exactly, it's just shallow. Your body is made of roughly 7 billion atoms. At death, biological processes stop, decomposition or combustion begins, and those atoms are gradually redistributed. Carbon into the air as CO2, water back into the water cycle, minerals into soil, nitrogen into new organic material. Within a few decades, physically speaking, there is no meaningful sense in which your atoms remain distinguishable from any other atoms of the same element anywhere else in the biosphere. A carbon atom that was once in your left hand is chemically and physically identical to a carbon atom that was once in a tree, a fish, or a Roman soldier 2,000 years ago. Atoms don't carry ownership. They don't remember whose body they were in. This is true, and it's often presented as the final word on the physics of death. You scatter, you rejoin the great cycle of matter, the universe recycles you the way it recycles everything. It's a nice thought. Cremation versus burial debates online often stop right here, treating the question as settled. Here's how thoroughly recycled you already are, before you've even died. Every breath you take contains, on average, several molecules of nitrogen and oxygen that were once inhaled and exhaled by every historical figure you've ever heard of. Not metaphorically, but as a direct consequence of how many gas molecules exist in the atmosphere and how thoroughly they mix over centuries. Calculations based on Avogadro's number suggest that your lungs, right now, almost certainly contain atoms that once passed through the lungs of Julius Caesar, Cleopatra, and every person who has ever lived and breathed on this planet. Your body is not a closed, isolated object that begins at birth and ends at death. It has always been a temporary arrangement of atoms, on loan from everything that came before you, and it will simply return that loan, on schedule, to everything that comes after. But this account has a massive blind spot, and once you see it, you can't unsee it. The atoms were never going to disappear. No physicist has ever worried about that. What physics actually has a genuine, unresolved problem with is not the matter that made up your body, it's the arrangement. The specific, irreproducible pattern of information that made those atoms into a functioning brain capable of having exactly the thoughts, memories, and sense of self that you have right now. Here's the distinction that changes everything. Mass energy is trivially conserved. Nobody disputes that. But information, the precise configuration, the pattern, the code, behaves completely differently under the laws of physics, and its fate at the moment you die is one of the strangest open questions in modern thermodynamics. To understand why, you need to burn something on purpose. Not your body, a piece of paper. Take a letter with your name written on it, in your own handwriting. Burn it completely. Every physicist agrees on the first part. The mass and energy of that letter are perfectly conserved. The carbon in the paper becomes CO2 and soot. The heat radiates outward and eventually warms the room, then the building, then dissipates into the atmosphere. Not one particle of energy is lost. The first law is satisfied completely. Now ask a harder question. What happened to the information? The specific shape of the letters, the exact words, your name, spelled out in your exact handwriting. Common sense says it's gone, destroyed, unrecoverable. You cannot look at the smoke and the ash and reconstruct what the letter said. But here is where physics gets genuinely uncomfortable, because the answer is not actually, yes, it's destroyed. According to the deepest layer of physical law we currently have, quantum mechanics, and specifically the principle of unitarity, information is never truly destroyed. Ever. Not in any process the laws of physics permit. The smoke particles, the heat radiation, the precise scattering pattern of every molecule that once made up that letter. In principle, if you could track every single particle with perfect precision, the information about what the letter said is still encoded in the universe. Scrambled beyond any practical hope of recovery, but not, according to fundamental physics, erased. This is not a fringe idea. It is one of the most rigorously defended principles in modern physics, and it is the exact same principle at the center of one of the most famous unsolved problems in physics today, the black hole information paradox, which asks whether information that falls into a black hole is truly destroyed or merely hidden in a form we don't yet know how to read. Now apply the letter to you. Your brain, at the moment of your death, is not just a collection of atoms. It's an almost incomprehensibly specific arrangement of roughly 86 billion neurons, connected by around 100 trillion synapses, each one holding a piece of the total pattern that constitutes your memories, your personality, your sense of being you rather than someone else. That pattern is, in the most literal physical sense, information. A configuration of matter and energy, exactly like the ink pattern on the letter, just vastly, almost unimaginably more complex. When you die, that configuration does not survive as a functioning structure. The precise electrochemical pattern collapses. Neurons stop firing in coordinated sequence. Within minutes, the specific arrangement that generated your consciousness begins to break down. And within a much shorter window than most people realize, sometimes just a few minutes without oxygen, the pattern is no longer recoverable by any biological process we know of.
To understand why information carries a physical cost at all, physics had to survive a 100-year-old trap set by one of its own founders. In 1867, James Clerk Maxwell proposed a thought experiment designed to break the second law entirely. Imagine a tiny, intelligent demon guarding a door between two chambers of gas. The demon watches individual molecules approach the door and lets fast, hot molecules through to one side while letting slow, cold molecules through to the other. Given enough time, the demon sorts a random, disordered gas into a hot chamber and a cold chamber, decreasing entropy, apparently for free, just by knowing which molecules were which. For decades, this seemed like a genuine loophole. It took until 1961, when Rolf Landauer finally located the flaw, to explain exactly why the demon can't actually cheat the universe. This is where the physicist Rolf Landauer's work becomes unavoidable. In 1961, Landauer proved something remarkable. Erasing information is not a free process. It has a physical cost. Every time information is destroyed, practically if not fundamentally, it must be paid for in heat, released into the environment as entropy. This is now called Landauer's principle, and it has been experimentally confirmed multiple times, most rigorously in a landmark 2012 study that measured the tiny exact heat released when a single bit of information was erased in a laboratory. Landauer's answer was this: Maxwell's demon isn't free. To keep sorting molecules, the demon has to keep making decisions, and to make room for each new decision, it has to erase its memory of the last one. That act of erasing, Landauer showed, is not thermodynamically free. It costs energy, released as heat, in an amount that exactly cancels out whatever entropy the demon appeared to save. The demon doesn't break the second law. It just moves the entropy cost from the gas into its own memory, and then pays that cost the moment it forgets. Information and entropy, in other words, are not separate ideas that happen to rhyme with each other. They are, at the deepest level physics has been able to reach, the same currency. Death, under this lens, is the largest, most complete act of information erasure a physical system can undergo. Not the destruction of energy, that's impossible, but the irreversible dispersal of an extraordinarily improbable pattern into the vastly more probable disorder of the surrounding universe. Your body's heat, released as you die and as you decompose or are cremated, is not just thermodynamic byproduct. In the deepest sense available to modern physics, it is the signature of information being converted into entropy, the pattern of you being traded for heat, exactly as Landauer's mathematics demands. And this single mechanism, pattern collapsing into entropy, is not unique to human death. It is, according to some of the most serious physics being done today,
possibly the same mechanism governing the fate of information falling into a black hole, and even, at the largest scale imaginable, the fate of the entire universe. The parallel is closer than it might sound. When Stephen Hawking showed in 1974 that black holes slowly evaporate over time, radiating particles now known as Hawking radiation, he initially concluded that this radiation was completely random, meaning any information about what had originally fallen into the black hole, whether it was a star, a spaceship, or a letter with your name on it, would be permanently, irretrievably lost when the black hole finally evaporated. For decades, this information loss paradox put Hawking directly at odds with the unitarity principle at the foundation of quantum mechanics, which insists information cannot simply vanish. The dispute became serious enough that in 1997, the physicist Leonard Susskind made a formal scientific wager against Hawking and his colleague Kip Thorne over exactly this question. And the resolution, still actively debated today, and connected to a concept called the holographic principle, in which the information about everything inside a black hole may be encoded on its outer boundary, is one of the most active frontiers in theoretical physics. Your death and a black hole's evaporation are, mathematically, asking the same unresolved question. When a pattern disappears from view, has the information actually gone, or has it simply moved somewhere we don't yet know how to look? Zoom out as far as physics allows. The second law of thermodynamics states that in any closed system, entropy, disorder, never decreases over time. It only increases, or at best stays the same. Applied to the entire universe, this leads to one of the most sobering predictions in cosmology: the heat death of the universe, a far future state, trillions of years from now, in which every star is burned out, every black hole is evaporated, and energy is spread so evenly across space that no further useful work, no chemistry, no biology, no thought is physically possible. Maximum entropy, perfect, permanent disorder. Under this model, every act of order in the universe, every star that formed, every planet that cooled into something capable of chemistry, every organism that arranged itself into something capable of thought, is a temporary, local rebellion against entropy, paid for by borrowing order from somewhere else and eventually returning it, with interest, as heat. You, specifically, are one particularly intricate example of this. For a span of decades, you existed as a wildly improbable pocket of order inside a universe that is, on the whole, relentlessly moving toward disorder. Your death is not an exception to this process. It is the process, playing out on the scale of a single human life instead of a galaxy. But here is the detail that most explanations of entropy leave out, and it's the detail this entire video has been building toward. Physicists are deeply divided over whether maximum disorder actually means information gone forever, or whether at the deepest quantum level, the information is still there, just spread so thin, so scrambled across so many particles, that no observer inside the universe could ever practically reconstruct it. The difference between those two positions is not a technicality. It is one of the most contested open questions in theoretical physics, and it applies exactly as much to a dying star as it does to a dying human. So here is the insight this video has been assembling, piece by piece. You are not going to be destroyed when you die, because destruction, total, physical annihilation, is not a process the universe permits. The first law forbids it outright. What actually happens is stranger and, in its own way, more precise. The improbable, ordered, energy-expensive pattern that was capable of reading and understanding this sentence will disperse into the vastly more probable disorder of its surroundings, exactly as Landauer's principle predicts, exactly as the second law demands. Your energy does not vanish, it redistributes, obeying conservation laws that have never once failed in the history of physics. Your information, the specific configuration that made you you, rather than any other possible arrangement of the same atoms, does not survive as a functioning structure, but whether it survives in some deeper, unitarily preserved, physically encoded form scattered across the universe is a question modern physics has not definitively closed. Not because scientists haven't tried, because the mathematics of information at the deepest level of reality is still genuinely unresolved. The same unresolved mathematics currently being fought over in the context of black holes, 100 years after Einstein and decades after Hawking first raised the paradox. Death, in other words, is not the universe answering the question of what happens to you. It's the universe handing you unfinished, one of the hardest open problems in modern physics. If this is the first time you've heard death described this precisely, not through religion, not through sentiment, but through the actual unresolved mathematics of physics, let me know in the comments whether that makes it feel more frightening or somehow less. There is something genuinely strange about sitting with this. Most of what we're told about death offers a clean answer, one way or another. Either everything continues or everything simply stops. Physics refuses to give you either of those clean answers. It tells you with total confidence that your energy cannot be destroyed, and it tells you with equal confidence that the specific pattern making you you will not survive as a coherent structure. And then, at the exact point where you most want a final answer about whether anything of you persists in some deeper encoded sense, physics goes quiet. Not because it doesn't care, but because it genuinely doesn't yet know.
That silence is not a failure of physics. It might be the most honest thing physics has ever told you. So here is where this leaves you. Not with an answer, because physics doesn't have one yet, but with three possibilities, each one taken seriously by working physicists today, and none of them provably ruled out. The first possibility is pure chance. Your pattern dissolves into entropy completely and permanently. Nothing about the specific arrangement that was you persists in any meaningful, recoverable sense. The information becomes so thoroughly scrambled across the universe's remaining lifespan that even in principle, no process could ever reconstruct it. Under this view, you are genuinely and finally gone, not in violation of physics, but as physics' natural entropic conclusion. The second possibility involves the multiverse. If certain interpretations of quantum mechanics are correct, the many worlds interpretation among them, then every possible configuration of particles, including every possible arrangement that could ever produce something functionally identical to you, exists somewhere across the near infinite branching of quantum outcomes. Under this view, you, in some form, in some branch, never actually stops. The third possibility is an undiscovered law. Physics has been wrong about final answers before. 200 years ago, energy and matter were thought to be separate, indestructible things, until Einstein showed they were interchangeable. It is entirely possible that our current understanding of information, entropy, and consciousness is missing something as fundamental as that, some deeper law connecting information to physical reality in a way we simply have not discovered yet. Physics will not tell you which of these three is correct. Nobody currently alive can. What it will tell you with total certainty is that your energy, every last joule of it, is going somewhere, obeying laws that have never once been broken, in a universe that has never, not once, actually destroyed anything. If this changed how you think about the physics of your own existence, the most useful thing you can do right now is hit like. It's the only signal that tells YouTube to show this kind of thinking to more people who need it. You began this video watching a flame go out, certain that something had ended. Physics has just spent the last 25 minutes proving you were only half right. If you want to keep sitting with the physics questions science hasn't finished answering, subscribe to Feynman's Mindset and watch this next. The black hole information paradox, the exact same unresolved question this video has been circling, just asked at the scale of a dying star instead of a dying human.